Okay, so good evening, everyone. I hope you are doing well in such rough times and you're keeping your mental and your physical health in a good conditions. Uh, Please join me. We are talking about what we love most, endodontics. I will be talking about some nickel titanium and instrumentation, and I will show you how to manage severe cases. Uh, let's just take a few seconds so we can begin. I hope you are enjoying. I'll wait another second for some viewers to come on. We all miss our clinics and miss practicing. Let's hope that we are able to do it soon. Okay, so we can start now. Now I can't see you, but you can see me. So, I hope you are doing well, everyone. Let's start by talking about some endodontics in the tough and rough times. Let me first introduce myself. I am Dr. Mostafa Kholy. I'm a lecturer of endodontics in the Faculty of Dentistry in the British University in Egypt. Also, I'm an active member of the Egyptian Association of Endodontics, and I will be talking to you for about 20 minutes about what we love most, endodontics. I would like first to thank Endostar Poland for giving us the opportunity to talk and to discuss what we love and to elaborate more and to open our mind. I gave a workshop over there a couple of years ago. They are wonderful people, so thank you Endostar for your kind host. So what is rotary nickel titanium main parameter? There is lots of nickel titanium instruments in the market and lots of illusions, lots of truths, lots of myth. There's lots of information, there's lots of misleading. So when you are buying a nickel titanium instruments, what are the key parameters that we are should looking for? Nowadays, nickel titanium is considered to be the gold standard of root canal instrumentation. We are not comparing anymore hand instrumentation and nickel titanium. We are comparing nickel titanium with nickel titanium now. So, what are the key parameters when you are selecting your instruments for your instrumentation? What do we want? We want an efficient instrument. We want a safe instrument. We want an ergonomic instrument. We want an instrument that can you achieve your proper shaping and your proper root canal instrumentation in shorter time, less cost, and especially with safety. So the first parameter I will be talking about is the cross section. As you can see here, it is an old parameter actually, the cross section of the instrument. Nowadays, we have several. Sorry, I'll go back. This one. We have several cross-section parameters of the rotary nickel titanium. We have the U shape, like here. We have here the U shape. Sorry. This instrument is called the U-shape cross-section. It's a very old cross-section of the GT and the profile. And we have the triangle, and we have the modified triangle, and we have some exotic asymmetrical cross-section like the K3. Nowadays it is always triangle or modified triangle. These are some very old cross section, but we needed them to evaluate our instrument and to see where we are coming. This U-shaped cross section diameter, we have something here is called radial land. It was advocated that it will keep our instrument centered in the root canal and avoid any transportation, but it is more efficient now. The triangle cross section and the modified triangle cross section and even the S-shaped cross section, because they are active cutting tips and there is the core of the instrument is strong and prevent its breakage. Why I talk about cross section of the instrument, although it is an old parameter and nowadays, because it gives an indication about the core of the instrument. What is the core of the instrument? It is the central piece of the instrument, which is solid metal, like here, like here, like here, like here. The more the core of the metal is wide, the more the instrument is stronger, but in the expenses of the flexibility. So larger core have strongest instrument but larger flexibility due to a lot of material is present there, it prevents its bending. Second, I will be talking about the rag angle. The rag angle, also it's an old parameter nowadays. The rag angle, it is the angle formed between the leading angle and the cutting tip when the instrument is cut in a perpendicular position. And we have, as you can see here, a positive rag angles and negative rag angles. When the angle is acute, is considered a negative rag angle, which is sharper but it is weaker. When the instrument is obtuse, it's a negative rag, it's a positive rag angle. It is stronger, have more cutting efficiency, but it is weaker. It is an old parameter also that we are not gonna discuss it because there is much more things that we are talking about. Also, we have the helical angle. It's a different angle. It's the angle formed between the long axis of the instrument and the flute of the instrument or the cutting edge. And the more the helical angle is wide, the more the instrument would be aggressive and cut more. Also, it is an old parameter. What is really interesting nowadays and the most discussed in the rotary nickel titanium system, the kinematics. The kinematics, it is the way the instrument will move inside the canal, the way the instrument will rotate. We have the first case, we have the continuous rotation instrument. It is the gold standard of the instrument. When the instruments rotate clockwise in 360 degree. It is good, it's my preferred kinematics, so when using it, it is the best for me. There is also reciprocation, which is EMAS 2008. Their aim was to reduce the stresses on the file by the counterclockwise rotation. So the file, when rotated clockwise, it will cut and will leave stresses by counterclockwise. Lots of people like it. I used it a little bit, but I prefer more the continuous rotation instruments. It is really, there is no evidence of superiority of any instrument over the other or any kinematic of the other. And the last kinematics we have is asymmetrical, or sorry, it is the up and down motion. It is very asymmetrical, not a rotation. It is when the instrument move up and down inside the canal. This is like the self-adjusting file. When the file enters the canal, and you put here a hose for irrigation, and the file continue to move up inside the canal. It is a different kinematic. It's not like the continuous rotation or the reciprocation. So this is a very, very new concept of dividing or understanding the classification of the rotary nickel titanium. You choose according to your preferred kinematics. For me, I like more the continuous rotation, although there is no difference between continuous rotation and the reciprocation instrument. The problem is with the up and side or self-adjusting file. It requires special devices, so require extra expenses on your clinic for you just to try it, and maybe you like it, or maybe it's held on the shelf with the other instrument you have. The other parameter is rotation mass. Usually the instrument rotate around. Usually the instruments rotate around its axis. Recently there is asymmetric rotation movement like Pro-Taper Next by Din Supply, like the Revo S before it. The instrument when it's moved alongside an asymmetric cross section, it moves like a serpentine movement inside the canal. They claim that it's provide better debridement and less stress distribution, as not all the file is contacted the canal. I used it a little bit in the past, but I didn't like it much. My technique of instrumentation was not suitable for using this asymmetrical motion because I need a file stronger inside the canal and well centered. Also, a parameter when selecting an instrument, this is either you can select a multiple system file or a single file system. I love them both. I cannot say which is better, but I prefer using more instrument to distribute more stresses on file rather than distributing more and more stresses on a single file. As the last parameter and the most important parameter nowadays is the alloy. Manufacturer busts their heads to achieve new design, new cross-section, new movement, new kinematics, but the really breakthrough was the alloy. The alloy of the Rotary nickel titanium was modified to a more flexible, more resilient alloy by heat treatment, where we can follow closely the canal anatomy and provide any mishaps during instrumentation. Usually, even with Rotary nickel titanium, there's tendency of the alloy or the file when it's encountered in the curved root canal to straighten itself, creating a zipping or a ledging. This is because the instrument is super elastic. With the new heat-treated alloy with the martensitic phases, the instrument is to have a shape memory while it preserves the shape of the root canal. So, what instrument should I choose, or what instrument should I benefit more in the root canal? Well, you must have a perfect balance between your kinematics, your alloy, your tactile sensation inside the root canal. Choose whatever you want, but it's most importantly to have a balance between your instrumentation root canal system and to understand how to select your root canal instrument system. So when talking about heat treatment, usually in the past we're using the austenitic or the austenite nickel titanium, where the instrument have super elastic and it have a high, very cutting efficiency, and it is resisting to torsion and resisting to twisting. But as we can say, the super elasticity have tendency to be straightened inside the root canal. When the file with a large core entered the root canal, it have the tendency to be straightened inside the root canal, causing a transportation or zipping. So the manufacturer thought that we should evolve our alloy to a better alloy, so they tend to use the martensitic alloy. Usually the nickel titanium has these two phases, austenitic and martensitic. They are interchangeable during the manufacture and during heat treatment. The martensitic alloy is more flexible, can be pre-bent because he has the shape memory property and have greater resistance to fracture, but it is also have a less cutting efficiency. Therefore, we must use the benefits of the two phases of the alloy together. So it is beneficial when the martensitic phase is heat treated a little bit or near the body temperature. It has both phases, martensitic and austenitic phases, which can benefit of both of our properties. And the Endostar, I've been using it for a little while now. I've used the Endostar E3 before the Azure came across. It has some limitation because of the alloy itself, but the evolute the instrument and the adopted the heat-treated alloy, especially heat-treated alloy with the Endostar Azure. The key feature of the alloy is that we have a safety non-cutting tape that allow us to move inside the root canal without creating any ledges or any perforation. It's pretty much a gold standard for any rotary nickel titanium instrument. But the most important here also that we have a variable pitch. To understand the pitch is the distance between two blades or two identical cutting edge. It's most important to have a variable pitch. As we can see here, we have here small pitches. As we go coronal, we have a larger pitch. The importance of the variable pitch is two things. If the instrument have not a variable pitch, as constant pitch, is to be like a screw. It will have a screw-in action inside the root canal, or what we call negative pressure. When applying inside the root canal, the instrument is sucked down inside the root canal due to screw-in action or the constant pitch. Also, the variable pitch provides us with better cleansing area. So here we have better cleansing area for the debris to come out and not be clogged inside the root canal. Also, we have, which is very important feature of the Endostar Azure that I like it the most, it has a modified S-shaped cross-section. As we talked about the cross-section, it's a really important factor about the core of the file. As you can see here, we have a minimal core of the file which provide us better flexibility, so we can follow more curvature, preserving more anatomy inside the root canal. Also, the modified S has a greater cutting efficiency than the other cross section. Also, we have a better debris with the cross section, better debris space, 37%, a better clearance for debris displacement. This is why this is the most of the key feature of the Endostar Azure, and this is why I would like it the most when shaping or preserving inside the root canal with severe curvature. Usually we have here the basic kit. It is the ergonomic of the file, or the system of the file. It's really good to understand, because as you can see here, it is color coded. The blue one is for side 30, the red 25, the green one is 35, 40 and 45, and the ring, number of ring, notify us the number of the taper. One ring is for 8 taper, 2 rings 6 taper, and 3 rings is 4% taper. Usually we can start with the basic kit or the starter kit, and we can go further for a small or big. What I like most of Endostar Azure, it is one of the only kits in the market with large taper instrumentation. You don't have a 45 or 4 very often in the market. So you start with the basic kit, and you have the small kit for small anatomies, and we have the large kit for example, shaping a palatal canal, or a distal canal, or a premolar, or even an anterior tooth with this instrumentation kit. Let's see how we can use it and how to benefit more of the unique file and unique alloy of this file. This is a case of a 23-year-old girl that have severe pain with thermal change, with hot and cold. The pain lingers a little bit after stimulus. Upon examination, there was normal percussion. So my diagnosis was that she had an acute, as you can see here, we have a large, carious lesion here, as you can see it, which is very close to the pulp chamber. So my diagnosis was acute pulpitis, or acute irreversible pulpitis requiring a root canal treatment. But before walking, let's take a look of the anatomy. This is a very important step that we analyze my cases. I don't. This is very important of the preoperative radiograph and how to examine the preoperative radiograph. Regardless, the 6 look at the 7 with severe curvature coronally. If you open this tooth and you went with your orifice opener, you will end up creating a ledge over here. So it's really important to examine the preoperative radiograph thoroughly to see anatomy and to analyze the case. As we can see here, we have a curved mesobuccal canal. This is not a severe curvature, but it is curved. We can create easily a ledge over here. We have a large palatal canal as usual, and we have also a small curvature in the distobuccal canal. So the first step after the access cavity preparation, this is how the tooth after the access cavity preparation, lots of bleeding, indicating that the case is hyperemic. Poor isolation, as you can see here, so I put on some liquidant to perfect more isolation. The first step, I take my orifice opener, which is a 30 taper 8, and I carry on into the canal with a small packing motion, 3 packs only inside each canal, in the presence of copious irrigant to keep my debris suspended and avoid canal blockage by debris. Look at the bleeding from the palatal canal. I use here the crown down technique, where I use larger instruments first, followed by smaller instrument. And actually this is my preferred instrumentation technique, and this is why I like more the Endostar Azure regardless the any other instrumentation kits, that is single lens instrument technique that requires that you are putting your instruments sequentially, each one to the full working length. When working with the crown down matter, usually you remove the coronal obstruction easier and more efficiently, and providing less stresses, less torsional stresses on the file when going small file inside the root canal. I will never go and put or insert an instrument to his full working length without proper coronal isolation, proper coronal pre-flaring. I usually prefer to use crown down method. So after the orifice opening, I took the 25.6. I use it in a small, gentle packing stroke, as we can see, very gentle in each canal. Only 3 to 5 packs, not exceeding 1 millimeter each. Even the instruments want to go, I will not push it furthermore. And as I told you, irrigation is crucial to keep our instrument, our canal lubricated and to avoid canal blockage. Then I put the 30.04 each canal. Here I prepare my mid root canal. As you can see, very gentle pressure. As you can see, as you can notice, I did not take working length. I did not take a glide path. I did not do any patency. Usually I don't do that unless I have the coronal 2/3 is prepared inside the root canal. And my rationale is to don't want to exert excessive pressure or excessive stresses, excessive torsional stresses on my glide path or on my patency files. Also, when providing proper coronal preparation and mid-root canal preparation, we also have a better tactile sensation for the apical patency and the canal curvature. Now I carried on with with patency and working length determination. Confirm here that we have curvature. I carried on for creating an apical glide path. Here I use the NT2, which is a glide path from Endostar also. They are beautiful. they have from 15 to 40 2% taper. They are really beautiful for creating a smooth glide path for further canal preparation. So after I prepared the coronal third of the root canal and I obtained my patency and working length and I obtained my glide path, now I carry on for apical finishing. Sorry. Here we go. Oh my god. So I went to finish the buccal canals to 30. As you can see, the beautiful alloy of the heat-treated alloy of the Azure, I can pre-bend to enter into the canal curvature. I use the 30.4 again, just a gentle packing motion to the full working length. Then again in the distal buckle. Then I will go to the palatal canal. So to repeat my sequence again, I use the orifice opening, here I use the 2506 in the root canal and the buccal canals, as you can see, and I'll finish it up with 2506 in the buccal canals, and I carry on more instrumentation or more enlargement to the palatal canal to 35.4. This is a master cone check. This is a post obturation. As you can see, I preserve my root canal beautifully. So I will repeat my protocol or my instrumentation technique. I'll summarize it. After coronal axis preparation, I just scout a little bit inside the root canal with a K size 8 to see if there is any coronal curvature. Then I carry on with my orifice operator, which was 3008, 3 to 5 pecks, 1 millimeter each, followed by the 2506, 3 to 5 pecks, followed by the 3004. Then I will carry on to take my working length and establishing a patency and a glide path. After establishing the glide path, I carried on to apical preparation or apical finishing, which is pretty much sequential. I use the 3004 followed by the 2506. And for further enlargement, I use the 3504 in the palatal canal to have such a beautiful anatomy. I would like to thank you for your attention. I will begin to answer your question now. So I will check your questions. Here we go. Hello everyone again. So I have a question here that said, do you use any kind of lubricant during treatment of curved root canal? This is a very good question. I love talking about a lot about the irrigation and instrumentation, and so usually I don't use any special type of lubricant. I don't use the Edita gel like RC Prep or Metagel or so. I usually use full concentration hypochlorite instrument during my whole instrumentation. It's been proven or it has been established, it's not very well known, but when using a gel chelator, a very viscous chelator, it creates a mud with the intestinal debris, exerting more torsional stresses on the file when you have fluid lubricants, not like you have a gel loaded or clogged with debris inside the root canal. Plus, it will enhance more apical blockage. You have gel loaded with debris, it can condense in the apical part. Usually I flood my access cavity with full concentration hypochlorite, and I use it during hole out instrumentation. Take another question. What is your cleaning and flushing protocol in obliterated root canals? Usually when we have an obstructed root canal or obliterated root canal, usually I will go for very small files first in the presence of a copious aerogel. I can fill here the canal with some Edita solution and not Edita gel, because Edita gel, as I mentioned, may clog and may cause some clogging inside the canal. So I use Edita solution with very small files. Just I have a catch inside the obliterated canal. Then I will go to carry on with hypochlorite during instrumentation. This is if the canal is obliterated due to a calcification. If it's obliterated due to a broken file or a ledge, there's no difference. I use mainly sodium hypochlorite, also full concentration. Let's see if I have another question. Yes. Can we use Endostar files in different motion, rotary, and reciprocation? Actually, yes. The Endostar, you can use it in both motion kinematics. You can use it in reciprocation and continuous rotation, but it is best to use it in continuous rotation. This is how the instrument was primarily designed to, so let's stick to it. I don't see any benefit, from my opinion, of the reciprocation inside the root canal. I used it a little bit in my early years, couple of years. I used the reciprocation motion. It's really good, it is really efficient. It's no different than the continuous rotation. So use whatever you like, but I recommend to use it in continuous rotation motion. I'll see if I have any question. Okay, it seems there is no more question. I would like to thank you all for your presence, and I hope this 20-minute talk about endodontics was beneficial. If you have any further question, be welcome to write in the comment. I will answer it for you. Thank you and stay safe, and goodbye.